So hi guys, it's back to Boolean Algebra. So in the last video I defined addition, multiplication, negation and showed you the distributive law and told you that any variable in Boolean Algebra can only have two values because those are the only two values that are allowed in Boolean Algebra. And then using the distributive law we proved a couple of expressions. And I also told you that in Boolean Algebra, well, by definition, when you talk about a law, you're just talking about something which is always true. In Boolean algebra, you can prove that an expression is always true by proving it for all possible combinations. Therefore, if you prove it for all possible combinations, that's equivalent to proving that it is a law. So how this is typically done, I told you, is using a truth table where you write all combinations of the variables that are in the system and show that whatever expression you're evaluating is true for those combinations. And it's just done in the form of a table. It's just testing all combinations but conveniently done in a table, and it's called a truth table. So if we have an expression a plus b, it can be written as a plus ab, which can be written as, I'm on this line by the way, which can be written as a plus ab, because a is just equal to a, which can be written as a1 plus b, distributive law, which is a times 1, which is a. So this in this whole set of steps, what we've actually proved in these steps is that a plus b is equal to a, and we've used the distributive law and the b plus 1 is equal to b law and a is equal to a law to prove that. Now you don't have to necessarily prove that expression from a basis of fundamental laws. You can just test it out for all possible combinations, show that it's true for all possible combinations, and therefore declare that it is true, that it is a law, it is always true. So like I said, this is done using a truth table, so let's just get on with it. So we have two variables in the system, a and b. So each of these variables can carry two values, so the combination can have 2 to the power of 2 values, 4, 0, 0, 1, 0, 0, 1 or 1, 1, as I've tabled here. Now if a is equal to 0 and b is equal to 0, then a plus b is equal to 0, because 0 plus 0 is equal to 0, and since a plus b and a are equal to 0, a times a plus b is equal to 0. This is just 0 times 0. If a is equal to 1 and b is equal to 0, a plus b is equal to 1 and a is equal to 1. So this stuff here is just 1 times 1, which is 1. If a is equal to 0, then this automatically is 0, because 0 times, just 0 times something, which is 0. Now here a is equal to 1, b is equal to 1, so a plus b is equal to 1. So a times a plus b is 1 times 1 is equal to 1. We have proved the expression because we showed that for all possible combinations it is true. Okay, now let's do another truth table for this expression, a plus ab plus ac. First, let us simplify this expression. A plus ab plus ac can be written using the distributive law as a1 plus b plus ac, by just, for the first two terms, taking out the a. 1 plus b is just simply 1. It's a law because 1 times anything, something plus anything is always something. So this is just a times 1, which is a, plus ac. So this is just, this whole thing is a, so it's a plus ac as we have on this step. A plus ac can be written as a1 plus c. 1 plus c is equal to 1, so this is just a times 1 is equal to a. So what we have proven in these series of steps is that a plus ab plus ac is equal to a. Now let's use a truth table to show this. Now we actually don't need, you can write down a is equal to 0, b is equal to 0, c is equal to 0, and then think, okay, a b is 0 times 0, so it's 0, so, and ac is 0 times 0, so it's 0, so, and a plus ab plus ac is 0 plus 0 plus 0, so it's 0. But it's not necessary. You can use certain simple clever arguments to do the calculations quickly. For example, we can have 8 combinations of A, B, C, and for 4 of these combinations A is equal to 0, and for the other 4 it is 1, where the combinations are 0, 0, 0, 0, 0, 1, 0, 1, 0, and so on. Each of them are unique if you check. I've made sure that they are. So whenever A is 0, that is for the first 4 values, AB is also 0 and AC is also 0. So A plus AB plus AC also has to be 0, right? And whenever A is 1, this component of this expression is 1. So if you have a 1 in an addition expression, the total sum will be 1, because there's already a something in it. Either this is something or it's nothing. Even if it's nothing, the whole thing will be something. So these will always be 1, because one component of it is a 1. The A part is a 1. So you've proven this law as well for all possible combinations. Now let's go back to simplification. Now let's simplify an expression that is slightly more complicated than what we're used to. The expression is C. Let me just separate these out so that it's clear to you what we're doing, right? Because it looks like the addition and the negation are merged together, sort of, right? So just give me 2 more seconds. Yep, that's it. So we're trying to simplify C, A plus B negated plus C plus D negated. Now distributive law, expand, you get AC plus B negated C plus CC plus D negated C on this line. So the CC is just C, so the whole thing is AC plus B negated C plus C plus D negated C. It's the same as the previous step, but CC has been written as C. Now this the final 2 expressions can be written as AC plus, well, that's not what I wanted. Give me a sec. Whoa. So yeah, this can be written using the distributive law, taking C out for the last 2 expressions, that it can be written as, take C out, it can be written as 1 plus D negated, which is just 1. So it's A plus B negated C plus C, and then which is what we have on this step. So let me erase that. Now these 2 equations, I mean not these 2 equations, what am I saying, these 2 terms, BC plus C is equal, B negated C plus C is equal to C B negated plus 1. That is AC plus C B negated plus 1. B negated plus 1 as a whole is just 1, so C times 1 is just C. So AC plus C, again using the distributive law, can be written as CA plus 1, which is equal to C. If I didn't confuse you with this one, just pause the video and look at it. I've written it down properly, so it should be clear. Okay, next time. Bye bye.